Hi, everyone. Michael St. John here from Red Hat's partner ecosystem. And today we have another great session around validated patterns. I want to introduce Brian Porter, who's been working with us quite a bit on the validated patterns with Intel and with Intel accelerators primarily. And Brian, you're going to talk to us today a little bit about some of the patterns that you've created. And I think there's like 8 of them out there now that you've actually created for acceleration. But today we're specifically going to be talking about the acceleration for automation for AI and security with Intel hardware around some of the validated patterns that we have out there. And so with that, I'll let you introduce yourself and take us through.
Cool, great, Michael, thank you. So my name is Brian Porter. I'm a solutions lead with Intel's data center group. Today we're going to talk a little bit about what Intel is doing with validated patterns. We've been working with Michael and his team for well over a year now on validated patterns, and really are seeing kind of the value that they're bringing for us just in both the work that we do in our labs and making it easy for both our customers and our partners to be able to leverage Intel features faster and more efficiently. So let's jump right in. So we'll talk quickly about validated patterns and kind of what they are. We're going to look at a couple of things that we're doing with validated patterns. And then we can run through some of the things that we're doing with our new GPU and validated patterns and walk through some of that as well. All right. So as you guys may well know, so Intel has been working with OpenShift for basically since its inception. One of the things that we're always trying to do is figure out faster ways to get our customers onboarded and leveraging, getting the value out of their CPUs and other Intel technologies. We have a wide range of tools and accelerators that are available on the CPU. AMX, which is we'll walk through them, but AMX is just AI acceleration on the processor. QAT, which is both compression and encryption accelerator, and then SGX, both SGX, which is for containers, and TDX, which does the entire VM for confidential computing. And then for the different use cases that we do or personas, there are a variety of different use cases that we'll put together for our users. All of the stuff I'm going to show you is available out on validatedpatterns.io, which is a Red Hat site that kind of hosts all of these validated patterns. Cool. So just really quickly on kind of how the stack works. So either Intel 5th generation, 6th generation technology, we've got a lot of tools that are built into our CPU, but to leverage them, you have to be able to use them in OpenShift. And one of the things that we want to do is, as our customers are getting in, we want to make them easier and easier to use. Whether that be having to have OpenShift find a particular capability, AI acceleration, find how to use it, right? Leverage it with other technologies that are out there, leverage it in the stack that you have. Our goal is to make that as easy as possible. So out on the validated pattern use site, so for Red Hat's OpenShift, they have made the validated patterns, which effectively will take the operators and configuration pieces that you need to make something work, right? The drivers that get you started, and they will, leveraging these, basically kind of walk you through a use case. One of the ones that we've used a lot is the multi-cloud GitOps. So multi-cloud being either your private cloud or a public cloud, OpenShift in AWS, right? OpenShift in Azure or wherever, or on-prem, right? So in a default data center with kind of the common tools, the cool tools that are going to allow your OpenShift environment to connect into your new OpenShift server, to connect into your OpenShift cluster, installing things like their Red Hat, their Git tools, and other kind of components that you need to get your data center environment set up. Medical diagnosis is another one that they did, where they're looking at more of a edge use case, right? And they're making that edge use case work with doing some basic AI to look at lungs, and we'll go into that one. And then what else? There's a bunch of others, but we'll walk through them as we go. All right. So the ones that we're going to talk about today, AMX, SGX, and QAT. I'll describe kind of what those Intel features are, and then we can show you how we make them work on Intel. So these are the validated patterns that are currently available. There's 7. Our goal at Intel is to just kind of keep creating them, and then we're validating them as we go through the different versions of OpenShift. The idea of the validated patterns is that they stay up to date and stay refreshed both by the Red Hat team and by the partners. So we're trying to be a good partner, and then as we do that, and as we do our reference architectures for the new versions of OpenShift, we're really kind of spending the time to go through and make sure that we're updating our validated patterns as we go. We have a number using AMX, which is Intel's AI feature, QAT, SGX, and then also Gaudi 2, soon to be Gaudi 3, which is our GPU. So AMX. So, you can either do your AI processing on a GPU or you can do it on the CPU. Particularly for classic ML, classic DL work, it is the CPU is more than capable of pulling that off, but having that offload and not actually kind of slowing down other work that's going on your server, right? Getting more out of the servers that you actually have. AMX, particularly as we move into Xeon 6, really extremely capable, able to run some of the large language models, particularly like 7 up to 13 billion for inference. But your classic ML, your classic DL, which is the bulk of the AI work that we're seeing today, extremely capable. But like all features, you have to enable it. You have to just kind of reference it, which is why we're using the validated patterns to help make that easier. SGX. So confidential computing. SGX enables secure containers, right? It's able to secure a single piece of software and the memory that's around it. We have done encryption at rest for a long time in storage. We've done encryption in transit, TLS, for banking and other information, now almost all websites, right? But the piece that we're missing, particularly in a virtualized age, is doing encryption actually in the memory stack and isolating our individual workloads to be more secure. We're going to show you a couple examples of that. Intel has both SGX, which is for the individual program, and PDX, which will do the entire virtualization boundary. But the goal is that as you're running more and more programs, more and more utilities on a server, right? Whether it be your server or in the cloud, you want to make sure that particularly for your PII, for your HIPAA, for your regulatory data, for your critical information, right? That is isolated, right? And that someone else snooping across the memory barrier, which is thin, can't see it. And then QAT. So QAT allows the offload for data compression, allows the offload for some crypto workloads, just makes it easier and faster, particularly as you're moving data East Coast, West Coast, as you're moving your backup data and your database, right? You're doing compression or encryption of that data to go to disk, all of that faster. All right, so the AMX validated patterns. Effectively through our tool sets, we've tried to make AI as easy as possible for people to access. We have tools for TensorFlow, PyTorch, and kind of all the major frameworks that are out there. But it's making sure that you have the right drivers installed so that as you try to go leverage these, you're getting the most out of them, and you're sure that from day one, your systems are set, ready to go, and all you need to do is enable it in the code. We're giving you some examples. Multi-cloud GitOps is just basically turning on those AI features, doing the node feature discovery to say, yeah, hey, if I'm going to use those, I want to make sure that particular Intel engine, right? Some of our older stuff, particularly our 5 or 6 year old stuff that you can sometimes find out there, Broadwell, Haswell, didn't have that, right? So it's making sure that it's enabled and then leveraging that tool. And then medical diagnosis, which is a really good edge use case, particularly for kind of the healthcare space, but also just giving you an idea of kind of other things you could do. General imaging and the capabilities that come with imaging. All right. So, effectively what we're doing is we're using the multi-cloud GitOps pattern that we are partnering with Red Hat with. We're giving you kind of a simple AI demo. We're doing the node feature discovery to make sure that it's on the right docs. And then we're enabling that, right? Giving you our multi-cloud GitOps. Again, it's installing kind of the common tools and frameworks that you need to get your server in the data center or on the cloud up and running. Then it's enabling AMX and installing the right operators to make that happen. And then giving you a sample so that you can then go and run your AI workflow. By the same token, right, we're using TensorFlow. We've actually gone through and quantized the model to allow the medical diagnosis to run that much faster for lung tissue, and we can kind of go through a little bit of what this does. It was a really slick demonstration of capability by the Red Hat team. What they're doing is they're actually bringing in a number of issues of looking for, I said lung cancer, but actually it's pneumonia. Looking for pneumonia through some images. So the images are coming in via something like a Kafka. They're getting processed, doing some general DL or deep learning imaging. They're going from there to an anonymizer. So it's anonymizing the data so that you don't have your HIPAA data out on those actual images, and it's placing it. And so it's a really good example of being able to leverage a CPU, leveraging the CPUs you already have in your medical facilities, and really being able to get the most out of hardware that you already have in your facility. Okay. This one has also been shown by Cisco. They've added to the validated pattern. The cool thing about the validated pattern is not only can we do them, but we can then hand them over to some of our partners and really allow them to run with it, which is awesome. So Cisco added then some of their drivers for their online management and tools within the Cisco server environment. We've shown this at a Red Hat Summer this summer, or Red Hat Summit this summer, and really got really good reception. Martin is actually part of the validated patterns team. We've seen him here on the SIG talking about validated patterns. But this is the team that actually put this demo together, and they were really excited to see it. This is that demo in the Lenovo booth with the Lenovo team. Again, everyone kind of taking and adding to it so that you have the drivers you need in your environment. All right, so let's talk about some of the others. One of the things that we also did was we created one that was a reference platform leveraging OpenShift AI. So rather than doing the model serving within OpenShift, we actually sent the model serving so that just the model serving portion of it is done in OpenShift AI, and kind of going with the momentum and kind of where the Red Hat team is going with AI. So you have the ability to both leverage in OpenShift natively, and then also with OpenShift AI. And again, so here we're adding the capability of doing just the model portion. So the rest of it is working in a regular workflow, but the model is actually being run out of OpenShift AI. We're doing a BERT large example in this case to a Jupyter notebook. right? And so that's the example on that particular case. So for SGX, we did a couple things. So one, so the ability to do confidential compute, we did a hello world that basically calls Grameen, which is an open source confidential compute framework from within OpenShift. The hello world app can be replaced with whatever you want to do, but it gives you a very good example of, hey, here's how to call SGX, have it work within OpenShift, kind of all the components you need. It installs the Intel device plugin, enables the features, and is a good place for you to get started if your company is interested in confidential compute. What we also did was we worked with the HashiCorp vault that was available as part of the validated patterns. And here what we were looking at was, again, I'd mentioned that things have already been encrypted on disk. They're encrypted in transit. But particular things like your HashiCorp has your keys, right? Your keys for your containerized environment. That's a really good place and a really good example of you being able to keep encrypted and keep safe the things that are most important to you. So where the rest of your containers in your environment may be running wide open, things like the keys that are kind of the keys to the kingdom for your environment, great thing to keep safe. So what we did was we created, took the HashiVault validated pattern, opened it up, and SGX enabled it leveraging Grameen, right? So that now it's the same app, but in this case, running an encrypted instance. We also went out with Istio, and for that mesh framework, so the service mesh, leveraged that so that we could do acceleration with QAT, right? And in that case, we're doing encryption of the compression decompression in the environment, making it so that the data is able to move that much faster on your OpenShift environment. Again, another example of things that you can do leveraging validated patterns, and something that you would want to do to make your environment that much faster and more capable. So, these are all examples of things we did. All of these are available online. Let's talk a little bit about the demo that we did at Red Hat Summit this summer. This was our Gaudi 2 before Gaudi 3 was released last month, actually earlier this month. We are in the process of updating this currently to work with Gaudi 3, and are really excited to see the performance improvements. So, in this particular demo, we're going to be showing an LLM using Llama. This is a 30 billion parameter model. Okay, what we did was we took the individual components that were using vanilla Kubernetes. We are running both as RAG and non-RAG, right, for answers. We're running this against an 8 GPU card, so 4 GPUs will be running one model, 4 GPUs with RAG and 4 GPUs without. This is how the resources are assigned. So all of this was put into a validated pattern and is available for anyone who would like to leverage it. But what we're showing is for the 70 billion parameter model, we're showing examples of kind of with and without RAG. This is using the OPIA framework that both Intel and Red Hat are leveraging to make RAG implementations a little bit more standardized, a little bit easier for industry to adopt, and also much more open, right? The idea being that open frameworks allow all of us to get in and really help push these technologies forward. So some examples of answers where a stock tuned LLM isn't going to get answers on who's presenting today at Red Hat Summit, but a tuned RAG version that has the information about the conference is going to be able to answer those, not hallucinate, not guess, right? Give you a much more concise version. For the validated pattern that's available, you can swap out the PDFs that are leveraging this to train to your environment, right? Or train being the wrong word, but basically to leverage in your environment so that you can take and utilize this. As we move it to Gaudi 3, it'll also be on Llama. I think 3.2 is the most recent one, but we're trying to make sure that we're keeping these up to date, that we're following along with kind of what is out there, so that you're getting the most out of your hardware and getting the most up to date solutions. So with that, are there any questions?
I might make a couple of comments. Like, one of the things that I really loved about the advanced matrix extensions or AMX is that you don't really have to turn anything on, right? It's there. You address it by running an AI workload against it. So that was really cool. And I think, in working with Intel around that, one of the things that I like to tell people is, hey, look, you want the right tool for the right job, right? And so certainly you're going to get a lot better performance out of like a deep learning accelerator like Gaudi or GPU or something like that. But those resources are really expensive. And so we see people like bursting things out to the cloud to take advantage of GPUs, or just having a small set of GPUs available in-house that they can parse out to and things like that. But wouldn't it be nice if you have all of this infrastructure that's Xeon based, Gen 5, Gen 6 Xeon based processors out there that will just take advantage of the AMX accelerators that you have available there. And it starts to become more of a conversation of, okay, when you're talking economics, you're going to parse out some of your heavy hitting performance models out to the GPUs or the Gaudi chips that you have out there.
Absolutely.
But for the majority of it, in your ML ops and your development and things like that, you might be able to get away with AMX acceleration on existing chips. And then also working with Intel around things like OpenVINO and edge deployments, you can use OpenVINO to help accelerate the inferencing while optimizing the model accuracy that you have based on what processes you have at the edge, for example. So
yeah, absolutely. We're trying to let you get the most out of the gear that you have. The ability to, particularly on some of the newer Intel hardware, to be able to do AI use cases is really there, and they're really capable. And more importantly, what people are finding is that they're spending a lot of money on a particular, like, where they think they're getting in with AI, and not realizing that those aren't the models they're going to use 6 months down the line once they've figured out where they want to be. So starting out with your Xeon infrastructure, seeing what is working and what is not, and figuring out what models are going to work for you long term, and then being able to leverage Xeon at the edge, being able to leverage Xeon in your data center where you don't have those GPUs, really gives you more capability, and it is something that we're trying to make sure that we're enabling that AI everywhere ecosystem.
Yeah, I didn't know that Cisco had taken out the AMX acceleration in their CVD. That's interesting. I have a call that I need to set up with Chris O'Brien over there, and I know of a number of other things we've done with them around validated patterns and some multi-partner plays with some other partners. But good to see this getting in there as well. They've been really good at adopting the validated patterns as part of their their test beds. So it's good news to see that.
Yeah, and the neat thing about validated patterns is, you guys built the original patterns. We added the Intel acceleration. Then the OEMs can then go and add their part, whether it be their out-of-tree drivers or other components that make it easier. And the whole thing is that all of us are working together to make it easier for customers to deploy their servers, right? Make it that much faster, give you faster time to market, and make it easier. Everybody's got a lot to do. If the server is able to help you get 95% of the way configured, right, with that small amount of customization for your cluster, your network, that's one less thing to worry about.
I know, like the quick assist technology, QAT, has it does acceleration for encryption and compression, as you mentioned. You showed a network activity, I believe, right, as part of the validated pattern.
Service mesh, yeah.
It's typically networking and storage where QAT is enabled, right?
Yeah, absolutely.
What type of use cases do you see, maybe for storage and as well as network?
So a couple things. So particularly for storage, it's a lot of compression. So compressing it before you store it, right? We're all trying to save money on our storage infrastructure. We save that data, and the data stays around, and everyone's storage is exploding. So compression is a really good one, and you're offloading that from the CPU to save your resources for something that you just don't need to worry about. And then encryption, whether it be SSL keys or other keys in your environment, being able to do all of these, offloading all of these facilities just makes it that much faster and more efficient, right? I mean, going back to AMX, like you're now seeing, AI in security tools. You're seeing AI in a lot of different frameworks where, it's not just that AI model you're running. It's the 50 other apps in your environment that are calling it as well, right?
Right. Yeah, and I kind of think of QAT as like the sweet spot would be in my mind. I keep going back to something like a business continuity, disaster recovery type operations, where you need to be able to compress and encrypt things over a network, maybe to a regional site or something like that. But also from a storage perspective, maybe you want to compress that while the data's in motion, and you need to secure it at the same time, right? And then it gets over to the other side, and it can stay in a compressed state until you need it for disaster recovery.
Yeah, so definitely business continuity where you're moving large files and doing large data movements. But data movements, data migrations, these are all really good use cases for databases, for traffic with things like Kafka. All of these where you're moving lots of files and you're trying to do it as efficiently as possible are all great use cases.
I have a question.
Sure.
Does the and it kind of piggybacks what you just talked about. Does the use case for the data centers remain pretty much the same in a virtualized data center scenario?
Yeah, absolutely. Yeah, and whether virtualized leveraging like Amazon or Azure, even like the federal government, when they were looking at kind of where they wanted to be, they saw that some of the players, CSPs, had like huge stacks of capability, and some of them had lesser. And when they were trying to figure out where they wanted to be, they chose OpenShift because it gave them a common across the platforms, right? And so being able to leverage something like a QAT on those platforms allows you to move your data, whether it's on and off prem or across mesh, particularly with the data cost of data transit sometimes is a good idea.
All right, thank you.
Yeah.
Hey, Brian, another thing that comes to mind, like, I mentioned AMX, you don't have to do anything special. You just run an AI workload against it. That's not true of SGX, though, right? Like the Secure Guard extensions requires an application to be written to make use of SGX. Is that right?
So yeah, so it's two parts
Okay.
to be aware of with SGX and SGX and TDX as well.
And TDX.
So one, the BIOS has to be enabled to allow for it. So Amazon and some of the others have specific SKUs that if you're going to run them in the cloud, if you're going to run particularly Azure, you need to make sure that you have those SKUs that are SGX enabled, right? But it's built into the last two models of Xeon infrastructure, right? So it has to be enabled. And then what you're doing is you're running Grameen or one of the container services to enable it. So once you have it enabled in your infrastructure, whether it be on-prem or in the cloud, particularly for on-prem, default is generally that it's on. So you've got the ability to use it. It's a matter of making the right Grameen calls to enable it. And so being able to leverage a validated pattern, which is why we created the hello world for OpenShift, right? All you're doing is you're basically looking at that framework and saying, okay, in place of the hello world, we're going to drop in our application.
Okay. And yeah, and from an SGX perspective, that works well for applications running in containers. From a trusted domains perspective, that is typically more for the overall deployment or the cluster deployment or a virtual machine or something like that, correct?
Right, correct.
And I know I talk almost all day, every day about about OpenShift virtualization. Is that something, I know we were talking about you potentially having support for OpenShift Virt in TDX? Is that something?
So the OpenShift container virtualization, like that is something that we're working very aggressively with the Red Hat team or your team on. That is going to be coming where you can do both host and container. We have Project Coco now, which is confidential containers, which will allow you to secure initial containers within OpenShift, but the larger package will be available early next year.
Okay, yeah, I saw a presentation around the confidential containers at KubeCon Paris this year, I guess, March. So that was based on an Azure platform. How has that changed since then, and what's on the roadmap?
Yeah, so that confidential containers is available in private preview for Azure. It is now available on GCP, and then it can be enabled in your on-prem infrastructure.
Okay.
Yeah, and it's available today on your on-prem infrastructure. Cool.
Wonderful.
Well, Michael, yeah, thank you for having us. Intel always enjoys working with Team Red Hat, and you guys have always been great partners for us. So thank you so much, and thank you for having me today. I hope everyone had an opportunity to learn a little bit about it. If you have questions, please validatedpatterns.io to check out any of the patterns that we've mentioned today. Thank you.
Okay, great. And I will take a moment to just do a shameless plug for what's coming up just in a few weeks. We'll be at KubeCon. The day before KubeCon, we have a OpenShift Commons Colo event going on, and on November 12th, we will have a couple of special interest group breakout sessions, and Validate Patterns is one of them. So if you are intending to be in Salt Lake City, November 12th, registration is free for OpenShift Commons, and please come join us in the Validate Patterns SIG. That's actually being hosted by Veeam this year, and so it'll be great to have conversation about the journey that people have taken going from reference architectures and using blueprints and different types of architectural designs. And the fellow we have on, Matt Bader from Veeam, will be talking a little bit about his experience in moving through all of that and adopting validated patterns as he's been building a pattern as well. So please join us there if you're going to be in Salt Lake City. All right, with that, thank you so much, Brian, and we will talk soon.
Thanks again, Michael. Talk soon.
All right, bye-bye.